In this video, we're going to go through the solutions to our first trigonometry assignment. Now, in the first question, we're going to be using Pythagoras' theorem to find unknowns in right-angled triangles. In the first triangle here, we've got a side length of 3, 2, and x. We want to find x. To enter this question, what we first need to do is label all the appropriate sides in the triangle. So the hypotenuse is going to be the side that's opposite the right angle. So the side that it cuts here. So we're going to label that C. The other two sides, we're going to label them A and B. It doesn't matter which one's A and which one's B, so long as they're not the hypotenuse. Now, we're solving for the unknown x, which happens to be the hypotenuse. So we go C squared equals A squared plus B squared. Then we substitute in our values. We're going to get x squared is equal to 3 squared plus 2 squared. This will come out to be 9 plus 4, and then that will be 13. Now, we might be tempted to say x is equal to 13, but x squared is equal to 13. Rather, what we're going to do is take the square root of both sides, and that will give us x is equal to the square root of 13, and we call it units. If we wanted to go one bit further, then we can bring our calculators up, and we can go option 1, clear the memory, and then we can go shift square root 13, and the answer is going to be roughly 3.61. However, as an appropriate solution, we could just leave it as x equals root 13. That's the exact value. Now, part B, we have a right angle triangle. However, only one side on the triangle is labeled, that's being this numerical value 2, which also happens to be the hypotenuse. So I'm going to label that C. And then for sides A and B, they're of a side length allocated as y. So what we can do is we can observe that we have the markings on the triangle here and here, which means that side lengths A and B are equal to y. So subsequently, we can say that C squared is equal to A squared plus B squared. However, A and B are the same length, so we can substitute y squared into both of them. Now, evaluating this out, we can collect like terms. So on the left we have 2 squared, but on the right hand side we're going to have 2 lots of y squared. And then we can evaluate the square on the left. So 4 equals 2y squared. Now we want to know the value of y. So in which case we go divide by 2 on both sides. This will give us 2 equals y squared. And then we'll reverse it such that y squared becomes the subject. And then we're going to square root both sides. So y is subsequently equal to the square root of 2. Now, evaluating what the rough answer would be, we can go square root of 2. And then we change it from exact to roughly. So I press the SD button, and it comes out to be 1.414. So the question might ask, or we might ask, when do we convert it from its exact form to its approximate form? And the answer is dependent on the question. If it doesn't specify, as seen in this question here, then you just leave it as a square root. But if it asks for 2 decimal places or 3, then you would evaluate it using the SD button. But the square root's a better way to leave it, in my opinion. Now, question 2, we have solve for the following unknown quantities. In part A, we've got a right-angled triangle, and we're given a side length, an angle, and there's an unknown side length. What we need to do is solve for this unknown side length over here. To do this, we first label all of the sides of our triangle relative to our angle of interest, theta. So theta there. So doing that, the z is opposite the angle theta. So we're going to call that the opposite. And the 15 is opposite the hypotenuse. So opposite the right angle. So we call that the hypotenuse. Now we have to use our ratios, cut and toa. And in this case here, we have theta equals 30 degrees. The opposite is equal to z, and the hypotenuse is equal to 15. So we have the theta we have the opposite, and we have the hypotenuse. So we're going to use sine. So we write sine theta is equal to opposite over the hypotenuse. Then we can substitute in our values. So sine 30 degrees is equal to the z over the 15. Now we have to rearrange to solve for z. So we're going to multiply both sides of the equation by 15. And thus we're left with 15 sine 30 is equal to z, or rotating it around, z is equal to 15 sine 30 degrees. Now bringing up our calculators, because we can't do the trig ratios in our heads just yet, we're going to go 15 sine 30, and that's going to yield a result of 15 over 2, or 7.5. So therefore z is equal to 7.5 units, because remember, this is a side length. So that's part A. Part B, we have a similar problem where we've got an angle of interest set to 60 degrees, so that's our theta. Then labeling the triangle relative to the angle of interest, the side opposite theta is called the opposite, and the side next to theta we call it the adjacent. The hypotenuse in this one is not used. Now next step is we write out all of our quantities. So theta equals 60 degrees, our opposite is equal to y, and our adjacent is equal to 5. Now we need to decide what units, or what we have and what we can do. So we've got the opposite and the adjacent. So we're using TOA. So we go tan theta is equal to the opposite over the adjacent. Now substituting in our values, we get tan 60 degrees is equal to, it's going to be y over 5. Now to solve this, we need to rearrange such that y becomes the subject. So I multiply both sides of the equation by 5, and that's going to yield 5 tan 60 is equal to y. I rotate the equation around, so I get y equals 5 tan 60. Then I bring up my calculator. So I'm going to type in 5 tan 60. That will give me 5 root 3, or roughly 8.66 units. So I can leave it in my exact form, or I can leave it in my approximate form. Okay, so that's A and B. Let's have a look at C and D. We have a right angled triangle. We have the angle of interest, theta, and opposite our angle of interest, we have the side length, O. And then in our case, the final quantity we're given, x, is acting as the hypotenuse. So we write out our values. We've got theta equals 15 degrees. Opposite is equal to 5 units. And the hypotenuse is equal to x. Now we go up and we have a look at the ratios we have. We've got the opposite and the hypotenuse. So we're using sine. So I write out the sine ratio. Sine theta is equal to the opposite over the hypotenuse. Now I sub in my values. Sine 15 degrees is equal to 5 over x. Now the difference between this one and the last one is such that our unknown is now on the bottom. So what we need to do is some careful maneuvering. Firstly, we're going to multiply both sides by x. Then subsequently, we're going to divide both sides by sine 15. Thus, isolating the x on the left-hand side. This will yield x is equal to 5 over sine 15 degrees. Now we bring our calculators up because we definitely can't do this one in our heads yet. And we go 5 over sine 15 degrees. And it's going to give us an exact solution. 5 root 6 plus 5 root 2. Or we can go for the approximate answer. and we press SD, and it will give us 19.32. And thus we solve the value of x in part C. Now let's turn our attention to part D. We have an angle of interest, theta, equal to 70 degrees. And then we have the opposite, which is equal to 30 units in length. And then we have the adjacent, equal to y. We are therefore going to use the tangent ratio because we've got TOA. Tan theta is equal to the opposite over the adjacent. Subbing in the values, we're going to get tan of 70 degrees. And then we're going to get the opposite is 30 units over y. Once again, we need to rearrange, so we multiply both sides of the equation by y. This will yield y tan 70, 30. And then we need to divide both sides of the equation by tan 70. This will yield y is equal to 30 tan 70. Next step is we say up we come to our calculator, 30 tan 70. And that gives us an approximate answer of 10.92. So our calculator can't give us an exact answer for this particular problem. So the side length is roughly 10.92. Alright, so that is part D. Now let's turn our attention to question 3. We want to solve the following for the unknown quantities. And in this case here, we've got an angle of interest set to theta, and we've got two known side lengths, 5 and 10. What we're going to do is we're going to label this triangle once again using our quantities. So the angle or the side length opposite is obviously the opposite, and then we're also working with the hypotenuse. So we've got our theta, our opposite, and our hypotenuse. So that means we're using sine theta equals opposite over hypotenuse. Subbing in the values, we're going to get sine theta is equal to 5 over 10, or approximately a half. Now, next step is we don't really care about what sine theta is, rather we care about what theta is. So what we need to do is we need to take the inverse sine of both of these, or both sides of the equation. So we go inverse sine of the left-hand side, so inverse sine of a half, and that's going to be roughly so we go shift sine 1 over 2, close it off, 30. So in this case our angle of interest, theta, is 30. Inverse sine of both sides. Okay, now in part B we have something that doesn't look so familiar. It's quite similar to the first question up here for part B. So we've got two common sides and we want to find the angle of interest here, but we don't actually have any numerical values on here. However, it's not a problem at all. What we're going to do is we'll start off by labeling our sides of interest. So relative to our angle of interest phi, we have the opposite side, and then we have the adjacent side. Now we don't know what these sides are, but we know that they're equal to one another, which we'll get to in a second. So we've got our theta, we've got our opposite, and we've got our adjacent. And our theta in this case is phi. And our opposite and adjacent, they don't have a symbol, so we'll just name them both x and x. Now, because we're working with OA, so TOA, we go tan theta equals opposite over adjacent. And then we're going to throw in the values that we've just got. So we've got tan phi, and we said that opposite and adjacent are equal to one another, and they're equal to x. So we get x over x. Now, because we've got x over x, we can simplify that down to tan phi is equal to 1. And then, taking the inverse tangent of both sides, phi will be equal to tan or inverse tan of 1. Now, Putting this in our calculator, we're going to get shift tan of 1, and lo and behold, we get 45 degrees. Okay, going down, we have question 4, solve for the following for all of the unknowns. So we've got this triangle here, the unknown, the opposite, or O, X, and Phi. Now, we could simply go straight in for the kill and we can solve the value of Phi over here because we know the angle here, and we've got the angle over here because we know if this is 90 degrees, then this side must also be 90 degrees. However, where we're going to start from is we're going to use our trig and we'll work out everything rather than doing it using the triangle properties. So the first point we're going to turn our attention to is this side O over here. Now, to be able to solve for O, we're going to label all of the sides of this triangle on the left-hand side. So going from our angle of interest of 60 degrees, which we'll label theta, we're going to go straight across, and the side O here, we'll call that the opposite. Now, we look at the hypotenuse, which is opposite the right angle here, which is a value of 2. So we've got the angle, the opposite, and the hypotenuse. So we're going to start off with the sine ratio. Sine theta equals opposite over hypotenuse. Then subbing in the values, we get sine of 60 degrees is equal to the opposite over 2. Now we're trying to find the value of O. So we're going to multiply both sides by 2, which will yield 2 sine 60 degrees. Now 2 sine of 60 degrees, we bring our calculator up. We get root 3, or roughly 1.73. Now, because we're going to use calculations that depend on this value O here, I'm going to leave it in its exact form, that is root 3. The next part is we turn our attention to the unknown X seen over here. What we're going to do is we're going to label the triangle relative to this quantity here, or this angle here. So we'll call this angle, let's call it alpha. Now, labeling our sides relative to alpha, we have the side O and we have the side X. Now, in our case, the side O is going to respond to our adjacent, and then the side X is going to be the hypotenuse. So we have alpha equals 60 degrees. We have O, which is equal to, right, adjacent is equal to O, which is equal to root 3, and then we've got the hypotenuse, which is equal to X. Now we've got the adjacent and the hypotenuse, so we're going to use the ratio cosine of theta is equal to the adjacent over the hypotenuse. Now, subbing in the values, we get cosine of 60 degrees is equal to root 3 over X. Now, the X is on the bottom. So for this example here, I'm going to flip both sides of the equation. So we go 1 over cos of 60, and then we get root 3 underneath X. After that, we have to multiply both sides by the square root of 3 to isolate X, such that it becomes the subject, and therefore we get an expression that looks like, we get an equation that looks like root 3 over cosine of 60. Evaluating this, we are going to get, and that will be approximately 3.46. Now, the final piece to the puzzle is solving the value of phi. Now, if we wanted to, we could use phi is equal to 180 minus 90 minus 60. And that's going to come out to be 90 minus 60. And therefore, phi would be 30 degrees. However, we want to use trig to do this. So this is a perfectly fine solution which you could employ in a test environment. However, we're not going to use it just for this question. Rather, we'll prove it using trig. So our phi over here, we'll call this angle of interest theta. We have the opposite and we have the hypotenuse. So we're going to use sine theta is equal to the opposite over the hypotenuse. The opposite in this case is going to be root 3, as seen over here. And then the hypotenuse is going to be 2 root 3. So we get sine theta is equal to root 3 over 2 root 3. Now simplifying this out, the 2 root 3's are going to cancel out. So it's going to be just theta equals the inverse sine of a half. And if we bring that up and put it in our calculators, and I should change that to phi, inverse sine of a half is 30 degrees, which is in agreement with the calculations we took over here. So this concludes the work solutions to assignment 1